The reason that we want to do this project is that we find that at the beginning of every semester, finding apartments and roommates is a big challenge for a lot of students. And many students encounter some problems when finding roommates and apartments, although the situation has always existed. There isn't a platform or a technique that can solve this problem. Students need to gather information through plenty of platforms and methods, which is very cumbersome. Therefore, we want to design a platform that can combine the searching results of roommates and of apartments. And we also want to combine filtering methods and machine learning algorithms for a recommendation system. And we think this market is very promising because there are no existing platforms that provide both roommate finding and apartment finding features. And as for data, we have two tables. One is a user table. This table contains more than 10 features and more than 3,000 rows. And the information in this table includes the first name, last name, email address, student ID, and preferences and hobbies of the user. And the other table is the apartment table. This table contains more than 10 features and more than 40,000 rows. And the information in this table is mainly about the location, the distance from school, and the price and the house type of the apartment. And we have multiple data sources, including Airbnb, Kaggle, and Meetup.com. And our data includes data that from user end and data from apartments end. And our data will be updated every time the user input their information into the front end. Here is the flowchart of our project. First, the user will input his or her information, and this information will be passed to the front end. And if the user wants us to recommend roommates, then we will filter data according to gender, hobbies, and etc. And then get roommates information from database, and then recommend roommates using our recommendation algorithms. And if the user wants us to recommend apartments, then we will get apartments information from database and filter data and calculate weights, and then recommend apartments. And the results will be displayed to the front end. And also, the user information will be stored into the database. And here is the system architecture of our project. As for data source, we have mainly three data sources, which is Airbnb, Kaggle, and Meetup.com. And as for database, we use BigQuery. And as for algorithms, we use K-means. And as for front end, we use Django.
Then let me give you a demo of our platform. The first function is to recommend roommates and apartments. Because our platform is built by Django, you can see this classical Django website. And when a user goes to our website, he or she will see this questionnaire, including this personal information and living habit. And in this personal information, this user have to provide his or her some basic informations like first name, last name, age, and email. That other users in your platform can use this email to contact this user. And what's more, we can give our recommendation based on your gender, your school, your major. Besides, we will have some other questions about your living habits like smoking, alcohol, and are you okay with pets? Then it's about living habit. In order to give you a really good recommendation, we have to ask you some questions about your budget, about which distance you want to live from Columbia University, and how many roommates do you want. Finally, when a user clicks the submit, all the information he or she provides will go to our backend, and we will use our algorithm to give you a good results. The results will show in another web page, including this roommate recommendation and apartment recommendations. And our platform can only give you some recommendations for roommates if you have a certain apartment you want to live in. Like you just want to choose the certain apartment you want to live in, and then give us our information about the roommates you are expected. And then you can submit this information, and our platform will show this apartment we recommend you. And what's more, if you have already got some roommates and only want to get some recommendations for apartment, you can also use our platform. You can choose this no to do want to some roommates, and then we will now show the roommates recommendation for you. If you just want to say something for a certain apartment, like get some information, our platform is still useful at that time. Like we have a list for all these apartments in New York, and you can find one you want to know, and then you can submit this questionnaire.
So now I am going to go over some of our algorithms and our reasoning of choosing our final algorithm that we use for the recommendation system. So the first and the simplest algorithm we looked at was called the Euclidean distance, which is simply the distance between two different data sets. So the distance from the target to all other users is calculated using this formula over here. And we're going to calculate the distance between our specific user to all the other users in our database to find the closest distance. And we're going to sort them in an ascending order, and we're going to take the top 5 users as our recommended roommates for the specific user. The other method we look at is called the k-means, which is a simple clustering algorithm that clusters all the users inside the database. We then pinpoint the cluster that our target user is in, and we will return all the other users within that cluster. So this method is similar to the Euclidean distance method, but it gets us a group of users within the cluster. Another algorithm we tried was called the cosine similarity. The formula is shown here, and it is simply the cosine angle between two n-dimensional vectors in the n-dimensional space. Since the difference between two users are calculated using the cosine function, so the closer the result is to 1, the higher the similarity in those two users. We reviewed our algorithms and listed their pros and cons, and we can see that for the Euclidean distance, it skews depending on the units of the feature, and it has better accuracy with low-dimensional data. That's why we do not want to use it, because we have 10 plus different features in our algorithm. So the actual algorithm we used was called the k-means algorithm, and it is easy to implement, and we can change the number of clusters to get the desired results, as we will discuss in the next section for model evaluation. The cosine similarity is also a pretty interesting method. We did not use it because it does not take the magnitude of vectors into account. which could be an important factor in our algorithm, because we want to recommend roommates based on not only their Boolean features, but also the features such as budgets and their desired distance to the university. As for the evaluation of our model, it is kind of tricky because we do not have a ground truth label to all the data sets. Therefore, we have to evaluate the model itself. The two methods or coefficients we found online that does such a job for us is called the silhouette coefficient and the Davis-Baldwin index. We adjusted those two different indices to get to the desired value by trying different models and different input parameters. And eventually the best results we get for a silhouette coefficient is 0.63. As for future work, we want to put the profile pictures of the users onto our front end, so that targeted user get a better looking at their recommended roommates. Also, we want to recommend the apartment not only based on the targeted user, but also based on the recommended user of that specific user, so that they have a higher likelihood of choosing our recommended apartments.